Hello, graduate students of Ag 490. This is week number 2 of the R graduate student edition. I'm your host, Kyle Brazier. All right, that's fun. So what you'll see in this week's folder is we're really starting to work on very basic use of R. We're going to be using base R in RStudio. With this data set that I'm giving you. So what you'll see in this data set is we have a little bit of raw data. Well, there we go. This R data that I've got here is just looking at a single factor. We're calling this single factor of treatment in a single year. This is our emphasis for this week, with some plots, 3 replications, and our tomato yield. Let's just walk through these 4 tabs. So this is the data set that we'll work towards. This is a 4-year data set for tomato yield. Again, only looking at yield under a no-till condition, a no-till with cover cropping, a tilled soil with cover cropping, and a tilled soil without cover cropping. Okay, so 4 treatments. Plots 1 through 4. The way that I designate my plot number, first value is the replication. So all the 100s are associated with rep 1, 200s with rep 2, 300s with rep 3. The next 2 are just my plot or my observation number, 1 through 4. And these are randomly assigned to our randomized treatments. And this yield value here, this is tomato yield in tons per acre. This is the data set that we'll be working with in class. I've got this saved in this Excel file, but it's also saved as a CSV. I'll recommend you use the CSV for R. Here's our experimental layout. Real basic, I made it up about 10 minutes ago. We've got our field map together for our first rep or our first block, our first replication, our second replication, block 2, and our third replication, block 3. And the treatments are applied randomly in these plots, right? These are randomly assigned as a no-tilled without cover crop, a no-tilled with cover crop, a tilled soil with cover crop, and just a plain tilled soil without cover crop. And we see that throughout these 3 replications, those treatments, those 4 tilled and cover crop use treatments, are applied throughout the field. So first thing that I want to talk about in today's class is really focusing on your data, right? This is an applied R class. The version of R that I'm going to work through teaching you isn't the prettiest, it isn't the most effective, it isn't the one that your computer scientists or statistical wizards would love. But what I'll show you is a very applied agricultural version of R, which I think is perfect for what we're doing. First thing you want to do is understand how to convert your field book data. This is what your field book should look like, to data that can be analyzed in R, okay? One thing that you'll want to do, and you can do this in R, you can do it here, is look for any errors, right? 36,000 kilograms per hectare. I'm sorry, this is tons per acre, isn't it? Tons per acre of tomato. Probably not likely. I'll go check my physical field book, that handwritten copy, and I see this is 36, not 36,000. So I'm going to change that here. If I keep that 36,000 in there, we're going to see a really big value for most of our means computations for our no-tilled soil with cover crop, right? The next thing we want to do is, when we use this in R, we want to get rid of this second row. In Excel, we can delete this, but we want to make sure that we keep our raw data in place. So we end up making a new tab. I'm going to make a new tab. This new tab's already shown to you right here in this Data 2017 R class. and it'll be available to you in this week's folder. But let's copy this for now. Instead of raw data, I'm going to paste that. Let's call it processed data. So we want to get rid of spaces in here. So we'll just call this tomato yield. We'll delete the tons per acre part. We'll get rid of this row. And honestly, that's all you really need. It's going to be more complicated when you use real data, right? If that 36 value is missing entirely and you go to do some work in R with missing data, you can put NA, but still you have to deal with that missing data. That's something that you'll have to work on data imputation within your own group. So reach out to your committee members, reach out to your major advisor, and figure out how you can impute missing data so that you can use R correctly and effectively. Other programs like SAS will do that for you automatically. R needs you to do that imputation more manually. Okay, so this tab here that we have, our process data, needs to look something like this, right? I advise for your own graduate research, filling out a field book that looks kind of like this, where you have your plot number, your replication, your year or your location, or you call it environment to combine year and location, your treatments, if you have different varieties in here, right? Have another column for that. We don't have that in this example though. And then after you get through all of these primary factors, then you start looking at your measurables. So this could be tomato yield, this could be soil aggregate stability, this could be tomato quality, right? Whatever you want, any of these other data that you've collected are, right? In most cases, when we do all this good work, we end up collecting more than just yield per se. Folks on the CIG project with Cindy, you're probably going to be looking at this whole suite of quality parameters. You would just put, say, bricks, its unit, percentage, and enter these values below, right? You could do the same for any of your other measured traits. Soil, aggregate, stability, right? So on and so forth. For today, we're only going to look at a single treatment, which is that soil management scheme, a no-till versus a tilled soil, and with or without cover crops. And we're only going to worry about tomato yield, right? At the end of the day, that's one of your farmer's biggest concerns. Does it yield? And we're only going to look at this in 1 year for this class. In later classes, we'll look at this over the course of 4 years, right? 4 years of, say, no-till or tilled or use of cover crop soils. With that, you will want to have this CSV file saved on your computer, and we'll move from here to R. The tidy data, right, making sure that you have a nice clean data set is important beyond belief. At the end of the day, you're going to go from this data set here to something that looks like this. You have no missing values. Anything that was missing in your raw data has been imputed. Again, talk to your advisor about that. You don't have any mysterious empty rows, right? We've deleted that row. And we're going to work from that. So with that, let's go to R Studio. All right, class. So we've talked about how to tidy up our data sets so far, and we've spent a little bit of time talking about why it's important to have a nice, clean, tidy data set. In reality, the data set that we're going to be working with today is going to be much, much, much nicer than what you'll generate in the field, right? You're working a lot of times with biological systems. You'll have plants that die, you'll have gophers that eat parts of your research plot, right? Things happen. it's up to you to work specifically on your project to figure out what happened, why it happened. See if you entered data wrong from your physical data sheet to your Excel data sheet. Troubleshoot other potential issues, right? Maybe, like I said, maybe a gopher came through and ate half your plot, right? So if you have half a plot, that's half a potential yield that you get to deal with. Figure out how to calculate yield from that and what percentage of your plot remains. You'll have missing data, right? Sometimes in these biological systems, your data sets just don't work out. You can work with your professor, work with your committee members to figure out how to impute missing data. In R, that data set needs to look as good as possible. With that, let's hop into actually using R. We're going to start off by making sure that we know how to annotate in R. Annotate is just making sure that we keep track of what's happening in our script. There are a lot of ways to annotate. We're going to work with the most simple, practical, basic, applied, in my opinion, version of annotation. This will make your statistics teacher cringe. I'm so sorry. This will make your R class teacher cringe as well. We're just going to do a bunch of little hashtags here. We're going to type in import the data. So what does that do? That means that this is not included, if you will, in part of that script. It reads out blue in the console, which is that bottom part that your script feeds into and reports out at. Nothing has happened so far, and nothing should happen in the environment area. This is just reporting what you have imputed or brought into R. And you shouldn't see any updates in your plots or packages when you have these hashtags. We're going to pretend like there aren't any packages in existence for right now. We're going to work in base R this week, okay? The way mine is organized, I've got my scripting area in the top left, this quadrant. Bottom left is the console and terminal. This is what's feeding back that data that I script, that information that I script. In the top right, we have our environment area. It's got history, connections. We can even import data sets in here. We're not going to do that today because we're all ambitious R students, right? And in this bottom right quadrant, we can make plots. We can use packages in the future, and so forth, right? So let's start in this script by importing a data set. This is a feat in and of itself, right? So when we're going to do this importing data set, you're going to need to start by setting your working directory. Now, your working directory can be found, our class, in the place that you saved your own file at. So if you saved this in this R class area, which I did, we should see something that looks like desktop, Chico Hire, R class, and then we see in that R class section the file that we're interested in. So you can right click the file that you're interested in, click properties, and you can see the path in this location section here, right? This says C, users, Kyle-PC, desktop, Chico Hire, R class. This is the path that we'll use. So let's go back to R. I'm going to close that out. I'm going to type in with those hashtags. Again, I'm using that to use that as my annotation tool. I'm going to say set working directory for tomato data. All right. Now we're going to do our first part of scripting in R. This is the fun part. We're going to type set. I can't quite remember. Okay, set something. We see that RStudio is pretty convenient. It pops up this list of options that start with set. So we can scroll through. I want something that's like set working directory. Let's see. Oh, this looks promising. Set WD. Get WD returns an absolute file path. Set WD is used to set the working directory. Okay, that's convenient. So that's part of why we use RStudio, right? It helps feed us in through this remove some of that guesswork and helps give us an option to go with. And we see it already set up these two parentheses, right? So we have to work within these parentheses. We're going to type in file.path. Oh, thank you, RStudio. Now we're going to type that path in. I'm going to do C, comma, whoops, users, Kyle, that's my name, dash PC, desktop, let's see, Chico underscore hire, then our class. Okay, let's see if this works. So if we do that, okay, we see that it's just fed through, but did it work? Let's find out. We're going to use this next step, which is paste. Get. We just saw this get WD previously to figure out which working directory we're working in. We see it shows up down here in the console. It says we're in the right working directory. So this worked. Great. So we have our working directory. From this working directory, we can actually bring in that CSV file. So let's see. Import the CSV file, which is also known as the data set. Okay. So we're going to start by naming this. We want to have this nice, easy name so we can work with it. We're going to call this class data. And this little arrow, that's setting that name, that's setting that class data name. It's like an equal sign. It's saying that this little abbreviation that we just made up, this class data, is the same as what I'm about to type after. So I'm going to type read.csv, reads a file in a table format and creates it to a data frame, right? RStudio works in these data frames, okay? And now I'm going to type in the name of the file. This is data2017 r class.csv. And I'm going to just jump ahead and say that the headers that are in that file are true. So I'm going to do header equals T for true. All right, I have a good feeling about this. Let's see if it works. Okay, it worked. This is good. Let's check it out. So we can go to this global environment area. We can click this and confirm that it worked. Ah, I didn't impute the right data set. This is the unpolished data set that I just brought in, where we have a no-tilled cover crop yield or tomato yield of 36,000 kilograms per hectare. This unit's not even right. We're working in tons per acre. You've got this whole wonky row for row number 1. Okay, we messed up. We have to go back to the drawing board. So let's see. I'm going to click back here. Oh, I think I wanted R class CSV. Let's double check. Yep, this is the right one. Okay, close that out, close that out. R class CSV. We can use this broom to erase, clear objects from the workspace. Yep. I'm just going to highlight all of this and run it again. All right, 12 observations of 5 variables. 1, 2, 3, 12. 1, 2, 3, 4, 5 variables, and those are our 12 observations. This looks right. This is what we were hoping for. We don't see any missing data, right? There are no NAs in here. We're working in column 1, which is numeric. Column 2, also numeric. Column 3, unknown. Uh-oh. Column 4 is a character. Okay. And column 5 is numeric with a range of 29 through 49. Great. So before we go too much further, we want to set our factors to factors, right? We want plot, rep, year, and treatment to be a factor. Character's fine too for treatment. And we want our yield to be numeric, right? That way we can work on those numeric column items, those characteristics as a numeric object. We want things like year, which could be viewed as numeric, or rep, which is viewed as numeric, as a factor instead of as a numeric value for analysis. So let's work through. Let's do the same thing that we did up here with class data. We're going to do class data. That's not the right way. Let's see. Let's do class data. So it's already popped that up for us. We can select a very specific column within class data with this $sign. We see that all of our columns are available to us now: plot, rep, year, treatment, and our tomato yield. So let's start with plot. We're going to say that class data data set, that data frame that we're working with, the plot column of it, we want to set as a factor. So we're going to do as dot factor. Thank you, RStudio. And we're going to pull it from class data. Plot. And this is important to capitalize plot if in our class data area that P is capitalized as well. And we're going to do this for plot, we're going to do it for replication, and we're going to do it for year. So I'm going to annotate because I'm really bad at that. Change numeric item, change factors labeled as numeric to factors. And then from here, we can just swap out plot with rep and do the same for year. So now we're changing our columns from numeric values to factor values. So let's run this. And it looks like it ran. We see that show up down here. If we mouse over, it says factor, factor, year is also a factor, and this is still numeric. Perfect. So now we can work with our data set. You'll have some errors that show up when you go through later on in this class if you don't have those columns labeled appropriately. Okay, let's start with some basic statistics. Let's do, we'll do all caps here because that's kind of fun. All right, so some basic summary statistics. Let's see, let's do means. We can calculate means. I'm going to do I'm going to call these data frames from here on out instead of data sets. So we're going to calculate the mean of our tomato yield in the data frame. Mean class data, selecting that very specific data frame. Then we can select the column that we're going to calculate means from. Click run, and it shows up down here. If I want to use that mean value, I can do something like tomato test, tomato mean yield, using that kind of that arrow, that what amounts to mean the equals button. whoops, can run that and it shows up in our environment, right? It shows up as a value. It's really just pulling that same thing that we have down here in the console, bringing it up to the values. Easy enough. What else can we do? We can do medians. Median of class data. We should see this show up down here, 39.5. Great. What else could we want to do with this? Maybe we want to look at quantiles or look at it from a quartile basis, right? Let's do quantiles. Quantile produces sample quantiles. Great. And we, of course, go back and set our data frame to start with. That's class data. So we labeled up here when we imported our CSV file. Or when we imported it, we said this is here on out known as class data. Whoops. And then we have that $sign to select our specific column. We're going to do yield tons per acre. Hit run. Okay. And this shows us that same range. Our lowest value is 29, highest value is 49. We see that when we mouse over, range of 29 through 49. It's a good sign. And we see our quantile values, 25th, 50th, 75th. Perfect. There are a lot of other summary statistics that you can do, but for the sake of all of our times and moving on, these are the more important ones to worry about. If you have questions, you can always use Dr. Google, great resource. But let's move into some more highly applied functions. So we're going to move on to really the most important R function when we're talking about base R, which is aggregate, right? R functions. So what are we going to do with this? We're going to calculate means for our given treatments, right? What we calculated for yield tons per acre was our mean across our 4 treatments. That's great. It's giving us information about the test, but I want to know, well, what my mean values are for tomato yield for our no-tilled condition or our tilled condition with cover crops, right? So we're going to use aggregate, splits that data into subsets, and it computes these summary statistics for each. Okay, that's what we want. We're going to pull from our data frame, class data, and we're going to do this a little differently, just for the sake of showing some ways of working in here. We can pull from a specific column with these brackets here, right? And we're pulling from column 5. Column 5 is tomato yields in tons per acre. Okay. And we need to tell it how we want this to be listed as. We want it to be list. Whoops, let's see what list says about itself. List functions to construct on a list. Great. Class data. And let's go back to this version. Let's pull it from treatment. Then we'll do comma mean. And will this work? I'll give you a hint, it shouldn't work. Something's wrong. We have to make sure that we have the same number of parentheses going through, right? It's not closed off. It's waiting for something else when that plus button comes up. So I'm going to run this twice. All right. What we see is that this showed up for us now down below in our lower quadrant, our lower left quadrant, where we see our group, which is no-tilled, no-till, gives us tomato yield of about 32 tons per acre. No-tilled with cover crop, about 35. Tilled, 45. Tilled with cover crop, 48. Okay, this is good stuff. So it's looking like we're getting about a 2 or 3 tons per acre boost of tomato yield when we use cover crop in this data set. It looks like our tilled soils, surprisingly, are giving us higher tomato yields. Well, hopefully when we collect more years of data for this or look at it in different ways, we can start getting a better understanding for why that tilled soil is boosting tomato yield by a pretty good margin. That's probably significant. And maybe we can see that if we keep it that way for 4 years, maybe that change ends up balancing out. We don't see as much of a difference between those tilled and no-tilled soils. Maybe that means that even though we're getting these really good tomato yields in these tilled conditions, that's not really the whole story, right? I mean, there's a level of soil health that we're really not measuring yet. Okay, so maybe next year we can say, well, look, we want to take these other measurements. All right, might be getting ahead of ourselves a little bit. Let's keep messing with this data. So let's see, what else can we do? Let's use this approach to calculate standard deviations. Look at that sort of variance in the data set. We're going to do the same approach, aggregate, class data. We'll do this again, just for the sake of simplicity. List, where this is where we break it up. Class data. The treatment column is how we want to break it up. And instead of saying means, we're going to calculate standard deviation, which is just abbreviated SD. Okay, yeah, that looks pretty good, actually. That's a pretty good data set. Now, if we want to use these later on, it's probably best for us to give these a name, right? We're going to call this, I don't know, tomato yield, and we're going to call this tomato standard deviation. Now, if I highlight these and click run again, these pop up here in the global environment area. So we can click tomato yield, and this looks exactly like what we saw down here, but now we have this data frame to pull from, right? It makes it more accessible to us. Now, the problem is if you have every little bit of this put in here, you're probably going to end up having a very full environment, and it's hard to keep track of. So just make sure that when you go through, you're able to keep track of everything that you're doing. Okay, let's make a bar plot with this. Let's visualize this a little bit more. Bar plot. Okay. Now, this is going to be a lot of work to do in base R. We'll see that when we bring packages in, we get a lot more control. It's a little bit more flexible, easy to work with. In base R, which is what we're focusing on today, to make a bar plot, we're just going to type in bar plot. Creates a bar plot with vertical or horizontal bars. And from here, we're going to, excuse me, we're going to start by setting our data frame, right? Calling a data frame into this bar plot. So here we're going to say tomato yield. We have to be careful that we're selecting the right stuff, right? We're just going to pull tomato yield in. And then from here, we're going to select our specific column that we want to look at. This is going to be yield in tons per acre. That's just this option here, this data frame, where we've got this group 1, which is our treatment. We have our yield in tons per acre for each of those treatments. So that's what we want to focus on for this particular bar plot. These will be the bars themselves, right? So our Well, let's actually see if we can just run it like this. We can. There's a lot missing on this bar plot, right? We see that there are 1, 2, 3, 4 bars. We don't know what each bar is. We've got an unlabeled y-axis and an unlabeled x-axis. We probably want to fix that. So what should we do from here? Well, let's say x label equals, we're putting these in the double quotes so that we're specifying it ourselves. Treatment, y label, what should we call this? This is yield in units of tons per acre. So we're setting these custom labels when we have it in these double quotes. Okay. Let's keep going with this. Let's go down a line. We want to make sure that this is our closing bracket so we don't forget it, or closing parentheses. What are we missing? So let's see if we can run it like this before we see what we're missing. Okay, so we've labeled our x-axis and our y-axis. So we at least know that these are things, right? You know, these are our treatments. We don't know what's what yet. We know that this is some measure of yield on our y-axis and units of tons per acre. But for this graph to be usable, we need to add some content to it. So let's see, let's do names.arg. This is a vector of names to be plotted below each bar or group of bars. Okay, that sounds pretty valuable. And we can do this, again, customizably, right? We can do with the C option, we're stating these on our own. We're calling them out independently. These are in order: no-till, no-tilled with cover crop, tilled soil without cover crop, and a tilled soil with cover crop. So we're going to put these in order. This is going to be no-till. We're using these commas to separate it out. Then we're going to say no-till cover crop, CC. This is going to be tilled. We're going to do tilled cover crop. Okay, let's see what we get. All right, so as expected, these are now labeled on our x-axis. That's great. What else can we do? Well, let's see if we can change our y limit, because this y limit is not high enough. We already know that we have a value of 45 tons per acre. I'm sorry, 47 tons per acre as our max bar height for the tilled with cover crop. That's well above the 40. So let's go back to this script up here. And let's do comma, and the function for setting a specific limit, start with the y-axis, LIM, limits for the y-axis, equals, and we're going to do this customizably. Again, we're going to use that C option. 0 through 60 is 0, 60. Let's see what that looks like first. Okay, 60 seems a little bit too high, doesn't it? Let's change that to 50. Perfect. That looks like a nice plot so far. You know, and this alone is pretty good. This is good enough for a thesis as it is. It tells the story that you want. It's a good start, is what it is, right? It's, if you're in a rush, you can just crank this out and you're set. What if we want to add a little bit more to it? Let's add some colors. COL, vector of colors, and we're going to use these colors. Again, we're going to customize them with that C option. We're going to set them with hex values. So when we use hex, it's 6 alphanumeric characters that follow a hashtag. I'm going to do 115599. That should give us a kind of blue color. We're going to do the same. Another slightly, what would it be? Maybe a slightly lighter blue. 335577. Okay. Now let's do a brown color. Brown's kind of fun. 775533 and 995511. What do you think this will give us? Looks like I forgot to put the hashtag in here, didn't I? Hashtag. Okay. And yeah, we've got a nice bar graph that we just produced. Our tilled items are blue. I'm sorry, our no-till items are blue. Our tilled items are brown. We can even change these two colors around so that the blue color means no-till, and then the darker color would mean without cover crop, right? You can edit it from here if you want to make this a little different, right? A lot of hex options that you can find on Google, but what we've done here is we've created a bar graph, a bar plot with this data frame, right? And you can make the same bar graph or bar plot in Microsoft Excel, right? This isn't really the strength of RStudio. RStudio's strength really comes in the package options, where you can do a lot more in terms of working with your data frame on a really quick level. You can work very, very robustly over the whole data frame all at once instead of going line by line. And you can make much better figures pretty easily in here, right? So we can export it, save the image, adjust the height and widths, maintain an aspect ratio, decide where you want to save it. What I'm going to ask you all to do for today's class is go through, make this bar plot. Maybe if you want to get extra fancy, you can figure out how to put error bars on this bar plot just by searching the Google, by bringing in this tomato SD option into this story. Maybe you figure out a way to add a line going across the x-axis. That'd be nice. Maybe you find a way to superscript the -1 for yield in tons per acre. But what I want to see is your final product, which is this bar plot that we just made. And I hope that your bar plot looks a little bit better than the one I just produced. So when you go through this week, go ahead and import your data, do some summary statistics, play around with that, work with this aggregate R function. But what I want you all to do is email me a picture of your bar plot. And my goal this week is for you to make this same bar plot. You already have the information here. I want you to use Google to make your R plot just a little bit nicer than mine. Again, however you want it to be. It can be superscripting the acres in that Y limit, or I'm sorry, in the Y label. That can be putting a line at that 0 point. So there's a nice line going across here. That can be bringing in error bars, which are just those standard deviations. That's up to you. But please send those to me by the end of the week, and I will talk to you all next week.